Welcome back to Water Quality in the Pacific Northwest. Today we're going to continue talking about surface water quality, and we're going to look at a second case study today. My second case study for surface water quality is about rain gardens, the use of rain gardens to manage storm water in the Puget Sound area. Here is an example of a homemade rain garden in the Puget Sound area. Basically, you have an area that's a depression in the landscape where water coming off the house and the roof and the pavement around the house puddle in this low depression area. And within a couple days, this water will seep into the ground instead of running off into the storm sewers. In areas that are wet, stormwater should be managed to protect surface water quality. Usually when we think of stormwater, we think of a storm drain and the water moving off surfaces into the storm drain, and the water here goes someplace. We generally don't know where it goes, but it usually goes one of two places. The storm water can move off the streets into the storm drains and sometimes empty directly into a water body, such as a river or the ocean. Or the storm water can go down a storm drain and go to a wastewater treatment plant where it's cleaned up and then it's sent to the water body. Most communities in the Pacific Northwest have a specific plan for managing stormwater. For instance, this is Hillsboro, Oregon. Basically, they have a separate stormwater and a sanitary sewer system, where the sanitary sewer system goes to a centralized wastewater treatment plant, and the stormwater is collected from the streets and it's moved directly into a water body. An alternative to sending stormwater to our storm drains and then to a surface water body is to treat it on site. Let's have the site retain the stormwater, and that will allow the stormwater to be used by local plants or to seep in and recharge the groundwater. We call one of the more innovative methods that is starting to being used the use of rain gardens, where we collect the stormwater, we allow it to percolate into the ground, and these are becoming quite common here in the Pacific Northwest. Rain gardens not only serve a function of preventing massive amounts of water runoff from urban areas, they can beautify your yard. Here's a rain garden that's really, really beautiful. It's actually a focal point in a person's yard. Populations and watersheds in the Pacific Northwest that get more than 80 centimeters of annual precipitation are rapidly growing. And these are some of our larger communities here in the Pacific Northwest. For instance, right now, about 11.5 million people live in these wetter areas of the Pacific Northwest, but this is a fast-growing area. Up to maybe 18 million people will live in these higher rainfall areas in our region. And our higher rainfall areas include urban areas west of the Cascades in Washington, west of the Cascades in northwestern Oregon, and north of the Snake River in Idaho. North of the Snake River in northern Idaho, not north of the Snake River in southern Idaho. One of the things we have to consider when we talk about stormwaters and we talk about rain gardens and stormwater management is the fact that the population of the region is rapidly growing. We see cartoons all the time on a worldwide basis that the world's population is growing pretty fast, but this particular cartoon, which shows the earth being overwhelmed by people, is actually quite true in the Pacific Northwest, where we are rapidly growing in our urban areas. So in our region, as areas develop, we pave them over. We build homes with roofs and instead of water percolating into the ground where the home site is, water runs off the rooftop. We build sidewalks, we build driveways, we build impervious surfaces where water can't percolate through and recharge groundwater. When we have more impervious surfaces, it increases runoff, and it actually increases the risk of urban flooding, which is becoming more of a concern in our region. So we can actually look at this from a good and bad standpoint. When we don't have impervious surfaces, this diagram on the left shows how that when it rains, in a typical area in the Northwest, about 40% of that precipitation is lost by evaporation. About 10% runs off into rivers, waters, maybe the Pacific Ocean, maybe into lakes. About 25% of it is percolated or infiltrated into the ground, shallow near the surface, and about 25% of it is deep infiltration, and it helps recharge the groundwater. However, we've created an artificial environment with growth. And if we take a look at the diagram on the right, here we have a bustling city. And instead of natural cover, probably 75% or more of the landscape is covered by impervious surfaces. This changes what happens to the annual rainfall. Still about 30% of it is lost by evapotranspiration, goes back to the atmosphere. About 10% of it becomes shallow infiltration water. About 5% of it infiltrates to deeper areas within the bedrock and recharges groundwater. But at least 55% of that precipitation is lost through runoff. So we have to have storm sewers, and this water moves off rapidly, and it's sent directly to a river or a lake or the Pacific Ocean. This is a far cry from the natural distribution. In the natural distribution, half the water ends up in the ground as a water supply for plants or as recharge for groundwater. Here in our urban area, only 15% of it actually ends up getting into the ground. A lot of it is just simply runoff. So when we have a high level of runoff, we have to be prepared to deal with that runoff. So impervious surfaces, and we're talking about roofs, driveways, sidewalks, things like that, they negatively impact water quality in lakes and streams by doing several things. First of all, they increase the velocity of water runoff, and this results in sediment delivery. The areas of the ground that are not covered with vegetation or homes may have bare soil. It rains, the water moves off rapidly, and some of that sediment goes with the water. If we take a look through the region, we see a lot of impervious surfaces on our land. Here's a diagram in an urban area. You can see these apartment complexes down here. You can see roads. You can see single-family homes. All these areas that are built on, that have buildings, are impervious surfaces, which means that the rainwater has to flow off into a surface water body. So when you move a lot of water off the land fast, impervious surfaces negatively impact water quality in lakes and streams by increasing surface water pollution. If you go out and you take a look at a parking lot before a rain, you'll see a lot of residues from cars. You might see some oil, you might see trash, you might see dust. It rains, and all of a sudden that oil, that dust is now dirt, and it's on the move, flowing toward the storm water, and that, or the storm drain, and that results in increasing surface water pollution. Again, in an urban area, look at this massive parking lot right here in the picture. Look at the roadway, look at the buildings. The impervious surface percent must be very, very high here. It must be 70, 80%. So again, impervious surfaces negatively impact water quality in lakes and streams many ways. It's not good for a hydrologic cycle because it reduces groundwater recharge. Basically, water that was meant to go back and replenish water in the soil and the aquifers doesn't get there, so this water moves off the surface very rapidly into our lakes and streams, and we end up basically with a deficit of water in our ground. Again, another diagram of a typical urban area. Look at all the surfaces that I would consider impervious. Roadways, parking lots, industrial building sites, probably single-family homes over here. We end up with an environment, compared to the forested area over here, where 70, 80% of the land is impervious. And when it rains, that water runs off very fast. It carries whatever surface pollutants are with it, and it damages our surface water quality. Runoff from impervious surfaces. We look at an aerial photograph here. What percent of the land is impervious? You see all these single-family lots. You can see that the building site itself is impervious. The roads to service the subdivision is impervious. There's driveways on all of these. So if you went in here, you would probably come up with this is low-density housing, you would probably come up with an impervious area of 60%. That means that the ground is going to absorb 60% less water, and you're going to have 60% more runoff. With that much more runoff, the runoff's going to be faster. The runoff's going to be more destructive. It's going to move chemicals. It's going to move soil with it, and you're going to end up with reduced surface water quality. In 2004, if we just take a look at some international statistics, it's estimated that impervious surfaces covered more than 111,000 square kilometers in the United States. In addition to that, about 1,000 kilometers are paved or repaved every year in the country. So we're adding to that 111,000 square kilometers at, it looks like a pretty slow rate, but these add up and they're permanent. In 2020, impervious surfaces covered more than 119,000 square kilometers in the U.S. So we jumped by 9,000 square kilometers in that decade. 60% of the impervious surfaces in the United States consist of the support system for the car. And that would include streets, driveways, parking lots. And then the other 35% are basically homes, industrial buildings, things like that. So currently in the United States, it may not seem like a lot, but currently 1.1% of the land area in this country is impervious surfaces. It's growing. The problem with 1.1% is that it's concentrated in small areas. Compared to the rest of the world, which has an impervious surface area that covers about 5% of the world. So we have twice the percentage of impervious surfaces in the United States that other countries in the world do. As one would suspect, if you look at countries with large populations, they have more impervious surfaces. China has the greatest amount of impervious surface, and that in China is about 67 square meters per person. The United States, with a much lower population, also has a lot of impervious surfaces, but on a per capita basis, almost 300 square meters per person of land is impervious. And if we look on a worldwide basis, areas with the most impervious watersheds would include the United States and China. put India up there, which will soon be the largest country in the world population-wise, and the highly developed countries. Many European countries have very urbanized, lots of impervious surfaces, and Japan. So do we build our stormwater systems better? We can. We can engineer them to better standards, but we also have an alternative that can be lower cost and probably more effective. So recently in the last 20-25 years, an idea to mitigate the impacts of impervious surfaces in the United States has been for homeowners to install what are called rain gardens. By definition, a rain garden is a planted depression in a person's yard that allows rainwater runoff from impervious surfaces to be absorbed by the soil and to recharge the groundwater. There have been a lot of studies on rain gardens, and one of the things that I think that's really important is studies have shown that rain gardens can reduce water runoff by up to 45%. And that means we're putting the water in a person's yard, and we're encouraging the percolation of that yard down into the groundwater to recharge the groundwater. Now remember in that diagram I showed you earlier in this lecture that in a natural system about 50% of the water that falls as rain goes into the soil for plants, or it recharges groundwater. So with rain gardens, we're compensating for that. We don't get to the 50%, but we're getting close. In addition to reducing runoff, we also reduce the pollution of surface waters, because by nature, impervious surfaces collect pollutants, oil and stuff from automobiles, trash, little bits of rubber, all sorts of things that you would see on a parking lot surface. So it also reduces the pollution of surface waters. And if these surface waters that are slightly polluted enter a rain garden, as that water moves through the soil, a lot of these things are detoxified. So these pollutants don't really end up in the groundwater. So we reduce pollution of surface waters, we reduce runoff, and we also improve groundwater recharge. Rain gardens can be installed by individual homeowners in areas that are high precipitation. An individual rain garden doesn't do much for a watershed. However, collectively, when many homeowners in a geographic area install and maintain rain gardens, substantial benefits can be afforded the entire watershed. And that's the goal of many communities here in the Pacific Northwest right now. I'd like to show you a little data from a survey that we did of homeowners that live in wetter areas. We developed this survey and we targeted residents in Oregon, Idaho, and Washington that lived in the wetter areas of the region. And of course, that would be west of the Cascades in Washington and Oregon, and in northern Idaho, where we get more than 25 inches of annual precipitation. We asked these people 7 questions so that we could understand their attitudes and aptitudes about stormwater and the potential acceptance of rain gardens. We sent this survey in 2017 to over 1,800 residents. To give you an idea of what these residents look like, first of all, we got a survey completion rate of almost 54%. This survey was sent through the U.S. Postal Service. It was a mail-based survey. 51% of the surveys were completed by men. almost 49% were completed by women. So we got a good distribution by gender. 41% of the people that completed this survey lived in communities that had more than 100,000 people. 16% lived in communities that had less than 7,000 people. And that's pretty much the way the U.S. Census Bureau tells us about our population in the Pacific Northwest anyway, that 40% live in communities that are bigger than 100,000, and far fewer people live in smaller communities. So let's take a look at some of the answers from these survey questions. If we take a look at the answers, we can get an idea about people's attitudes. First of all, we asked if the person lived in a rapidly growing area. And we divided the answers into people that said they came from a community with more than 25,000 people, or they lived in a community with less than 25,000 people. Do you live in an area, a rapidly growing area? When the community size was greater than 25,000, 70% of the survey respondents said yes, that their area is rapidly growing. When we were looking at smaller communities, about half the people said the area was rapidly growing. So yes, there's a perception out there that communities in the Pacific Northwest are growing pretty fast. Our wetter communities in the Pacific Northwest are growing pretty fast. Census data backs that, and people also realize that. Second question, do you think that the potential for flooding is increasing in your neighborhood? Very interesting answers. Didn't really matter what the community size was. A majority of people thought that the potential for flooding is increasing. More so in large communities, a little bit less so in small communities, but people are more aware that flooding is becoming a bigger issue. Now, whether they get that from the news media or from their own personal observations, we're not really sure, but we tried to follow up on that and ask them why they thought this was so. Why is flooding getting more severe? So the next question is, what do you consider the primary reason for the increased threat of flooding? If we look at people that answered the survey from communities greater than 25,000 in size, almost half of them, 46%, thought that pavement and development was a major cause for the increased threat of flooding. That's pretty good. Almost half the people believe that. And that's the right answer. That's the major cause. If people came from a smaller size community, communities less than 25,000, if you look at the primary reason for increased flooding, the number one answer was climate change, quickly followed by over a third of the people had no idea. Less than 20% thought pavement and development were the main cause, and only less than 10% thought that sewers. But I think it's really important here that, one, people are seeing that the increase of the threat of flooding is increasing, and two, there is a link. The people see the link between development and more pavement. Means there's less area for rainwater to infiltrate the ground, such that it moves off the ground faster, and it swells our rivers. So if we kind of summarize that, residents believe that the potential for flooding is increasing. Residents of larger communities, communities with more than 25,000 people, cite that an increase in impermeable surfaces is a major reason for the increased flooding threat. I'll have that changed on the PowerPoint slide that you get. An increase in impermeable surfaces is a major reason for the increased flooding threat. Residents of smaller communities didn't have a coherent answer. They were a little bit all over the place. They cited climate change, they cited pavement, and a third of them didn't really know an answer. So our next questions on the survey was, does flooding adversely affect surface water quality? It didn't matter what size of community you came from, 3 out of 4 people basically said that flooding adversely affects surface water quality. So that's a given. So how do we protect surface water quality? We have less flooding. How do we have less flooding? We don't have as much, we want to prevent as much water from running off in fast events as possible. Also ask the same question about groundwater quality. Does flooding adversely affect groundwater quality? If we look at the answers, first of all, we didn't have a majority of people that gave a single answer. We had 40% of the people say, yes, flooding does adversely affect groundwater quality. I think that's because people recognize there is a relationship between surface and groundwater quality, although a lot of people didn't know. So first of all, they see what they can see outside. They see a lot of surface water running off. They see the things that are in this runoff water, and they see the relationship between flooding and poor surface water quality. Groundwater quality, they have some ideas, but they don't really know because it's something that's sight unseen. If we look at some of the demographics, let's start with does flooding adversely impact surface water quality? If we look at ages, the one thing that we can see is younger people were more likely, people that were between 30 and 50 were more likely to say that flooding adversely impacts surface water quality than people that were older than 50. However, still more than 2/3 of the people over 50 thought that there was a big relationship between flooding and poorer surface water quality. So a majority of people in each age group. If we ask the same question about groundwater quality, the numbers are a little bit lower, but there is a good relationship between whether people think flooding adversely affects groundwater quality and age. Generally, the younger the person was, the more likely they were to say that flooding adversely affects groundwater quality. The only difference here was in the 70-plus age group, where they were a little bit more likely to see the relationship. Does flooding adversely impact surface water quality? What about formal education for the public? We divided people into 5 categories. People who do not have a high school diploma, people that have a high school diploma as their last formal education, people that have some college, they at least went to a semester of community college, people with a college degree, bachelor's degree, and people with an advanced college degree. You can see there's a good relationship between formal educational level and the adverse impact of surface flooding on surface water quality. If you didn't have a high school diploma, 6 in 10 people thought that there was a good relationship between adverse surface water quality and flooding. As your education became more advanced, 8 out of 10 people felt this way. And if we ask the same question for groundwater quality, does flooding adversely impact groundwater quality? You can see that formal education level has a big impact. A majority of people with an advanced college degree said, yes, there is an adverse relationship here. The less formal education a person had, the less likely they were to see the link between flooding and poor groundwater quality. So to kind of summarize this, over 70% of the people that participated in this survey in wetter areas of the Pacific Northwest recognized the link between flooding and reduced surface water quality. Conversely, the linking between flooding and reduced groundwater quality was recognized by less than a majority of people when we go to groundwater quality. So surface water quality, people saw the strong linkage, less of a linkage when we talk about groundwater quality. Again, groundwater quality is something people can't see. Surface water quality, people see. Okay, then our next couple of questions on the survey asked about rain gardens. We asked people if they know what a rain garden is. Based on community size, there was a little bit of difference. People coming from larger communities, over a third of the people knew what a rain garden was. When we got to smaller communities, only about a quarter of people knew what a rain garden was. So this is kind of new information for the average homeowner. Even though rain gardens have been around for a long time, they're just starting to proliferate in the region, particularly proliferating in the Puget Sound area. If we look at gender, females were much more likely to know what a rain garden is. We also asked people if they knew a rain garden user or they knew of somebody who had a rain garden. The numbers were lower, but females were more likely than males to know somebody who had a rain garden in their yard. If we look at age, the demographic factor of age, knowing a rain garden definition, this was not very distinct. NS means there's no significant difference between the age of a person. And whether a person knew a rain garden user or not, it didn't really depend on age either. These were non-significant information. If we looked at the demographic factor of education, we got significant differences. People with college degrees were more likely to know what a rain garden was than people with less education. People with a college degree were almost twice as likely to know what a rain garden was compared to people that did not have a high school diploma. Also, people with a college degree were much more likely, or some college, were much more likely to know a person who actually had a rain garden than people with less formal education. Actually, some people with some college were more than 3 times as likely to know somebody that had a rain garden than a person who did not complete a high school diploma. We look at community size. Females or community size know the definition of a rain garden. People in the communities that were sized between 25,000 and 100,000 were more likely than people living in smaller communities or larger communities to know what a rain garden was. People in those communities between 25 and 100,000 were also more likely to know a rain garden user than people in smaller or larger communities. Pretty interesting. It shows that people in the communities of the size 25,000 to 100,000 either have better public outreach or they're better connected. So some summaries here. Females were more likely than males to know what a rain garden is. Age did not impact knowing what a rain garden was. Residents with college experience, some college or a college degree, were more likely to know what a rain garden was. And residents living in communities sized between 25,000 and 100,000 people were more likely to know the definition of a rain garden than those people living in smaller or larger communities. As far as knowing a rain garden user, females were more likely to know somebody in the neighborhood that had a rain garden. Age didn't impact whether you knew somebody with a rain garden or not. So again, kind of summarizing the data. Knowing a rain garden user. Residents with a college background were more than twice as likely to know someone using a rain garden as people with a high school diploma or less. People living in communities with 25 to 100,000 people were more likely to know other users of rain gardens. So it's that middle-sized local community where people actually know. So what I'd like to do in just the last part of the lecture is to talk about the basics about building a rain garden. There is lots of good material on the web. Washington State University has lots of materials on building rain gardens. Washington State University has a very active rain garden installation project in the Puget Sound area, where they actually have programs where they go out and they show people in the community how to build great rain gardens. Probably the best source I found that's accessible, widely accessible to people, comes from Family Handyman. And here is the website for that. And basically, I'm taking materials from Family Handyman about the basics of a rain garden and just showing them to you on how a step-by-step guide on how to build a rain garden. Again, you want to live in a wetter area where there's a lot of runoff. Building a rain garden. This can be an asset for your yard, but it's also an asset for the environment. It's an asset for the homeowner because they solve their excess water problem. To build a rain garden, you don't need all that much. Simple tools. You need a level, you need a spade, and you need a wheelbarrow to move soil. Those are your tools. In addition, you need some materials. You need some river rock, probably 1 to 1.5 inches in diameter. You need some decorative rocks and boulders to make your rain garden area attractive. You need some landscape fabric. You need some native plants and grasses that will grow well in your area. And you need some PVC pipe because you want to funnel the water away from your driveway. You want to funnel the water away from your downspouts on your roof. You want to funnel that water into the rain garden. So a rain garden is basically a plant pond, a garden bed that you plant with special deep-rooted plant species that can tolerate wet conditions. The plants you choose helps the water rapidly seep into the soil away from your house. So the plants should help you in this. They should absorb some water. They should be able to withstand very wet conditions. And 90% of the time your rain garden is dry, so mature plants should be able to also stand dry conditions. Now what you do in building a rain garden is you're directing rainwater away from the stormwater system. So you direct the rainwater on your property away from downspouts, away from your driveway. You can do this using a stone channel. From your rain gutters, you just build a little stone channel so the water ends up in your rain garden. Or you can actually connect PVC pipe to your rain gutters and funnel it underground into your rain garden. So what the rain garden is, it's basically capturing the water. And when it's properly designed, the rain garden will capture the water after a rainfall event, and it will puddle in the rain garden. But within 1.5 to 2 days, that water disappears. It's absorbed into the soil. It's absorbed by the plants, or it's going deeper in the soil and eventually will end up in the groundwater. But that water disappears pretty fast in 1.5 to 2 days. So you don't have a flood situation in your yard. A lot of people say, well, if I'm going to have a rain garden, I'm going to have ponded water. What about the mosquito problem? Well, you got to remember that the rain garden is designed to use the water in 1.5 to 2 days. So the water drains into the soil before the garden becomes a mosquito haven. So that's one problem you solve there. What about an area where I have really heavy rainfall? Another issue people talk about is, what about chemicals and pet waste? Not much of a problem. Rain gardens prevent this waste from going into the storm sewer. This waste goes into your rain garden. And when this waste, which is dissolved in the water, percolate into your soil, you have microbes in the soil that detoxify any chemicals, detoxify your pet waste, which is basically organic materials. The waste percolates into the ground and is detoxified again by the microbes before it enters the groundwater. So that should alleviate some of the fears. Okay, so let's actually build the rain garden. Let's look at a step-by-step guide. There are 6 prominent steps into building a rain garden. Basically, you start out, and again, refer to the reference at the beginning of this section. It's a really nice reference. It's a step-by-step guide. If you're interested in building a rain garden, there are rain garden associations in Western Washington that can do this. You can create the rain garden by building a berm in a low spot in the yard. Then you build swales or channels to move the runoff water from your gutters and higher parts of your yard to this low spot where the rain garden is. There's good diagrams in this publication. Here's an example. Here's a rain garden out here way in the front yard. Basically, you've got swales or channels basically coming off the downspouts of the house. It goes through rocks and ends up in your rain garden. So after a rainfall event, same thing. An underground PVC pipe is basically collecting the runoff water from this gutter on the home to the rain garden. So the rain garden's in a low spot so that any water just naturally moves to it. Remember, this rain garden's only going to be really wet after a major rainfall event. Most of the time, this is a pretty dry area. So it seems simple enough. You have these channels, whether they're open channels that are lined with stones or PVC pipe that's underground that goes from a rain gutter to the rain garden. Once you get the water in the rain garden, the water is absorbed into the soil through a network of deep plant roots. Now, we just don't plant one plant. We use a mix of plants that's adapted to your area and to different water depths. So you'll have some shallow-rooted plants and some deeper-rooted plants. So if you have the right mix of plants, you're going to use the water pretty rapidly here. Again, we only want the water ponded for 1.5 to 2 days at a time. And then the water is absorbed into the soil and the area is relatively dry once again, waiting for the next rainfall event. Second step, where do you locate the rain garden and what kind of slope on your land do you need? You need to check the slope of your yard, and that's why you have a level and a board, a long board. To make a rain garden work effectively, you need the water to move away from the high spots and the rain gutters. You need a slope of 1 inch in 4.5 feet, or you need a 2% slope for water to flow into your rain garden. If you don't have that slope, you need to do some major landscaping to create the slope and to improve the drainage away from your house and foundation. Remember, it's just wonderful to get the water away from your foundation. The rain garden protects your foundation. As part of step 2, you need to locate your rain garden where rainwater will feed into it from downspouts, driveways, or low points in your yard. And in low points in the yard, you'll probably use underground PVC pipe to get that water over to your rain garden. How do you channel the water? You lay attractive river rock or run an underground PVC pipe to channel the water away from a downspout into your garden. So the location of your rain garden is important. It needs to be in a low area. It needs to be low enough that it can collect water from downspouts and driveways if you want to. And you want to make sure your rain garden is at least 10 feet away from your home. And this protects your foundation. Just the fact that a rain garden moves water away from your home and protects your foundation is an asset for the homeowner. If you didn't care about water quality at all or surface water runoff, the fact that water's channeled away from your foundation is a plus enough reason to build a rain garden. Now remember, you're going to get a heavy precipitation event every once in a while, and the precipitation is going to be so high it will overflow your rain garden. For the 2 to 3 times you get a heavy precipitation event, you have to create an overflow zone, a slightly lower area on one side of your rain garden with stones that will channel the water, the excess water from your rain garden away into the storm sewer system in your neighborhood. So you need to consider that. Don't locate your garden over a septic tank or over underground utility lines. Call the National 811 number to have your utilities marked before building your rain garden. So stay away from over your septic tank because the water will not leach correctly if you build it over a septic tank. And you don't want to get tangled up with utilities and in your digging process electrocute yourself. The next thing you need to consider, step 3, is the depth of your garden. Determine the size and depth of your rain garden based on how quickly your soil absorbs the water. Average rainfall event should fill most of the garden, but that water should drain away into the soil and be used by the plants within 36 hours, a day and a half. If you go to that publication I referenced, you can calculate the size and depth of garden you should have. First of all, you dig a small test hole in your yard. You fill it with water and see how fast it drains. And then there's a way to calculate the water runoff that would be coming down the gutters. And you could calculate the size of the rain garden you need based on this. So an interesting graphic, profile depth. So here's a cross section of a rain garden. Originally, this is a side view of your front yard. When you build your rain garden, basically you've got a berm on one side of it. So basically you have a little potential pond here, and you basically create the depth when full of water based on your calculation for how much rainwater you're moving away from your property. You only want to capture as much water as will sink into the soil in a 1 to 1.5 day period, or 24 to 36 hours after the storm. So you dig a hole in your garden, the size and depth of a large coffee can, fill it with water, time how long it takes for the water level to drop. If the water level drops a half an inch in an hour, the soil drains an inch in 2 hours. At this rate, the garden soil will handle 12 inches of water in 24 hours. And you can calculate the ideal depth of the garden in inches. Again, go back to this publication if you're interested in building a rain garden. There are several publications that show you exactly to figure out how much water is going to come off your property based on rainfall and the roof area of your home. And if you know something about how fast water moves through the soil, you can calculate how big your rain garden needs to be, which is step 4, your garden size. Estimate the volume of water that would flow off your roof during a 1-inch rainfall. And then you work from there. Some of these rain gardens are gorgeous. You plant the right species of plants. It's a showpiece for the home. Okay, you've done your infiltration calculation. You figured out how much water is going to move off your roof in a 1 hour, in a 1-inch rainfall event. You can estimate the volume of water that would flow off your roof during a 1-inch rainfall. And you do that calculation and you can see how big your rain garden should be. Most of the time in the wet areas, we're talking about, a home with a 2,400 square foot home that would have 4 downspouts. And you'd have 1 inch of rain in a 24-hour period. You probably need something like a 10 by 10 foot rain garden. Refer to the publication for the actual size. So basically what you're doing is you're estimating the volume of water that would flow off your roof during a 1-inch rainfall. So this is all engineering calculations. It's simple to do. A homeowner can do it. People that have experience with rain gardens would be glad to come out and help you do it. And if you've got a community with several rain garden people that have rain gardens, people are very willing to help each other. Okay, you've done that. Then you have to select the plants. Plant selections for rain gardens are fairly standard for certain geographic areas. If you're unsure, talk to your local extension agent. Your local extension agent can tell you the types of plants that would do well in a rain garden in your community. Very simple diagram. Let's say here's a rain garden. It happens to be 12 by about 5.5 feet in size. Looking down from the top, here's your channels coming in from your rain gutters right here. And they planted lots of different plants, moderate moisture plants, high moisture plants, things like sedges and asters and iris and foxgloves and sedges again, sage, which is a little bit drier, artemisia, daylilies, psidium, artemisia, lavender, coneflowers, all a big different collection. Typical plants that you find in wetter areas of the Pacific Northwest that do well in rain gardens include asters, daylilies, iris, sedums, coneflowers, artemisia, sedges. They're just some examples of plants. What you do is you choose plants that have average to moist water requirements on their tags. You're also choosing perennials because you want once you build your rain garden, you want these plants coming back every year. So you're not having to do too much maintenance on your rain garden. You position the plants that have average to moist water requirements in the deepest part of the rain garden. Now you also have to remember that some of these plants that love water, you have to be a little bit careful. You don't want to choose just water-loving plants because remember, your rain garden's usually dry. Your rain garden's only wet after a rainfall event. Try and select native plants. They're adapted to your climate. So if you're into native plants, this is a great way to display them. Try native grasses, wildflowers, and shrubs. Native plants not only soak up the water well, they're good for soil aeration. Again, your plant selection. And then finally, step number 6 is your rain garden needs tender, loving care, TLC, for the first year after you plant. You need to baby your garden during the first year. Once those plants become established, very little maintenance will be required, but you need to take care of it very lovingly for the first year. You mulch with shredded hardwood mulch, and you weed regularly because you want your planted plants to thrive and take over. So the TLC, tender loving care, is very, very important. In the first year, you're not set up to have your rain garden function 100%. You dig a notch into your berm the first year to allow half the water to flow out of the rain garden the first year, because the younger plants will have difficulty dealing with too much water. Once they're older, they'll do okay. But in the first year, you only want your rain garden at about half capacity. You want to add large decorative rocks at the garden entrance to prevent heavy rain from washing away the young plants. So in those spots where the water is coming into your rain garden, put some big rocks there, because you don't want those little plants washed out in the first year. You need to water your garden during dry spells during the first year. You need to make sure that rain garden gets about an inch of water per week. When you get to that second year, the plants are established. You fill up that notch that you built, you took out of the rain garden to allow it to only be at half capacity. You fix that the second year, and if you selected your plants right, and if you've nurtured those plants so they really take over, your rain garden will be pretty much maintenance free. So again, this is an at-home opportunity to protect surface water quality. You get a neighborhood with lots of rain gardens, and collectively the community can really reduce surface water runoff and improve the water quality of existing surface waters. Thank you for your attention. A big storm comes in, we get 1, 2, 3 inches of rainwater. Well, if you have heavy rainfall, it should be no problem, because the rain garden is designed in a way to handle the heavy rainfall. If you have heavy rainfall, you build the garden such that if you have so much rainwater, the water will overflow the rain garden into the storm sewer. The rain garden is not going to dispose of all the rainwater, so that in a heavy rainfall event, the extra water will overflow the rain garden, and then it will go into the storm sewer. You're still doing something good. You're still capturing about 70 to 80% of the rainwater. So if you have heavy rainfall, you've got to realize the rain garden has still done its job. It's moved water away from your house and your foundation, and it's also reduced the amount of water headed to the stormwater sewer system. 5 to 40 times greater than runoff from an equivalent area of grass. So if we compared an urban area to a grassy area and let it rain the same amount, the runoff would be 5 to 40 times as great in the built-up area with lots of impervious surfaces. Now, that means that all this water is lost to runoff, and it's going to adversely impact surface water quality. But we also know from recent history here in the Pacific Northwest that where we start creating impervious surfaces, we also increase the incidence of flooding when we have major rainfall events. So impervious surfaces are something that we have to deal with. Again, we're going to deal with them more and more as time goes on in the Pacific Northwest, because these wetter areas in our region are going to grow from over 11 million people to possibly 20 million people in the next 25 years.